What's happening, dogs? Mr. Allen here. We got ourselves a crazy mathematical modeling problem here. We are making a box with no top out of a 26-inch by 20-inch piece of cardboard. What is the maximum volume you can make this box, and what would the dimensions be? All right, so what the heck's going on here? So we have this piece of cardboard that is 20 by 26. Now what we're going to do is we're going to take out each one of these quarters, we're going to snip them out with some scissors, and then we can fold these edges up to create a box with no top. Okay, well that would mean then that this would be my height right here, right? This little length right here is going to be my height, as well as this little length right there. That's also going to be my height, okay? Because when I fold it up, that's the part that's going up, that's my height. So all these guys are going to be heights. Now what about my other two dimensions, like my length and my width? Well, this 20-inch side right here is going to, well, if I took out the height to make those folds up, what's this little bit right here? That's one of my other dimensions of this box, right? This rectangle inside here is the base of my box. The folded up, those are my heights. So how am I going to get this length right here? Well, that would be 20, but subtract the height here and here, so 20 minus 2h. Then how am I going to get this length right here? Same idea, except for now it's out of 26, minus this h right here, and that h right there, so 26 minus 2h. So I now have my length, my width, and my height of this box. What's the formula for the volume of a rectangular prison? Well, volume is equal to length times width times height. Note, the only time cursive is acceptable these days is if it's in a mathematical formula, okay, or in a diagram, if it's a letter from grandma, right, or you're signing your name. Other than that, keep cursive out of my life. All right, moving on for my personal agenda here. So that's my volume as a function of length, width, and height. I want it of just one variable. So for this one, since everything is in terms of the height right now, I can write this volume as a function of the height. So check this out. We got volume, as a function of the height, quick save, equals, well, I'm going to have my height. I'll just throw that guy out there first. Then I'm going to have one of my other dimensions, length or width, so we'll say 20 minus 2h. And then I'm going to have the other one, which would be 26 minus 2h. So that is now a volume formula in terms of one variable, which means, oh, you guessed it, dogs. Let's bust out that TI. So we're going to head into our y equals, right? I'm going to hit y equals, and I'm going to plug this guy in. Now what I'm going to do is I'm going to hit zoom standard, zoom 6, so we all start in the same exact spot. And we're probably going to see a portion of this graph here. It looks like just a blue line right down the center. What the heck does that mean? Well, oh, and I see a little bit more right on the side here. So I need to adjust my window. Now, what type of function is this going to be? Well, this is going to be a 1, 2, 3, a cubic function. So if I were to do a rough graph right here, I know that I'm going to have, well, a point at 0, comma 0. So if I plug 0 in, it's going to give me 0. Here, I'm going to get 10. And over here, I'm going to get, looks like 13. All right, so a little bit further. So I'm going to have some kind of a cubic that looks maybe like this. Okay? Now, the part that I'm concerned with on this graph, let's think about that. The part I'm concerned with is between this value here and this value right here. And why is that? Well, between 0 and 10 would be all of my possible dimensions here. Because if I go to 10 or beyond 10, this one right here becomes a negative dimension. I can't have a negative length here for my box. That's not going to work, right? If I go to 0 or past it, now I'm going to have 0 height. That's not going to make a box, right? So I got to be between this 0 and that 10 right there. That's my realistic domain for this particular problem. Those are the heights that make sense within the context of this problem. We could ask that question. I could say, hey, what heights would make sense in the context of this problem? Between 0 and 10, okay? So now I can see almost everything that I want. I'm going to go a little bit further to the right. I'm going to hit window, and I'm going to go with 15 for my max. For my X max, excuse me. And then for my Y max, I'm just going to go for it, man. Let's go to like 5,000, okay? I'm going to hit graph. Let's see if we can see this thing. Maybe. Okay, I went pretty high there. But can I see the max of my graph? Yeah, it's right there. Boom, we got it. All right, so let's find that max. I'm going to hit second calc. I'm going to arrow down to maximum. And now I'm going to go to my left of that maximum, hit enter. Then I'm going to arrow to the right to get my right bound. And then I'll hit enter one more time. And boom, I have my maximum here. We've got ourselves, let's see, we got X would be, and I'll put this point right up here, 3.7367, 3.74, comma, and then 867.195, so 0.2. 867.2. Woo! Just squeeze that in there. All right. So what does this mean in the context of this problem? Well, this right here would be my height, one of my dimensions, and this right here would be my volume. So to answer the first part of this problem here, what would the maximum volume be? My volume would end up being 867.2 inches cubed. Lovely. Lovely. Now, how in the heck would I get my other dimensions here? Well, my height is 3.74, as we said, right? Now, the other dimension, my width or my length or whatever you want to call it, is 20 minus 2h. Now, this is the only time where I'm going to say, we're good on the yo row. We've rounded. This is our height, so I'm going to use that value in there to find my other dimension. That way, everything adds up correctly. All right, so 20 minus 2 times 3.74, that's going to give me 12.52. And then I got to get one more, so 26 minus 2 times 3.74. And I'm going to get 18.52 again. So these are my 3 dimensions that would make up this box. And if I multiply these together, it's going to be pretty darn close to there. Again, it's slightly bit off because of the rounding, but it's what we had to do in this particular problem. Now, that was pretty dang crazy, awesome, and dope. See you guys later.